Hey everyone, I'm Amethyst and welcome to my second FNAF fan game devlog. I know a lot of you subscribe to see my progress on this, so I hope you won't be disappointed. This is the second devlog in this series, so if you haven't seen the first one, check it out in the description or in the video card in the top right. At the end of my last devlog, I presented a list of goals I wanted to achieve for this video, which is shown on screen now. Those goals were to finalize all the animatronic designs, finish all the reference sheets, model one animatronic, block out the map, and start coding the animatronic AI. I'm glad to say that I not only achieved all of these, but surpassed them. Starting with the first two goals, finalizing the animatronic designs and making all the reference sheets. After drawing the first iteration of the owl and receptionist's reference sheets, I turned to my YouTube comments and read it. I made a post on the Five Nights at Freddy's subreddit asking for critique on my animatronic designs, and I got quite a bit. When it comes to the cat and bunny animatronic, critique was few and far between, which I was quite happy about. Those two are the designs I'm most confident in and believe are the strongest. Out of the two critiques I got, the one I implemented was adding a rose somewhere on the cat's design. I thought it made sense for a magician. I made the rose the same pink as the bunny's, but I'm not sure if I like that color on him. Most of the critique I did get was for the owl and receptionist animatronics, which I expected to be the case. Those two were pretty bland compared to the first two. Rather than going through every single piece of critique I received and implemented, I'll simply show the list on screen. Pause if you want to read through all the changes I made. Anything you see that is unchecked likely means I'll be adding them in the modeling phase or implementing it as a mechanic. For the owl, the fixes mostly consisted of making his design more visually interesting, as he was pretty bland before. I think he looks a lot better now. Someone also suggested giving him a security outfit, since he's supposed to be a security animatronic. I thought that was a good idea, but at the same time, didn't like how it would look. I don't really think he needs to look like a security guard to be a security animatronic. I mean, just look at the puppet, who's also a security animatronic. As for the receptionist, most of the critique I received for her was related to her creepiness. I personally felt like she was the least creepy of the bunch, so that was the specific critique I asked for in relation to her. The advice I received was extremely helpful. So helpful that I ended up making several versions of her face and making another Reddit post asking which one was the best. Most people voted for options 5 and 6. The uncanny wide smile is undoubtedly a lot creepier than the grated mouth. Plus, it's more FNAF-like. Technically, Face 5 won by 1 vote, but I ultimately went with Face 6. Both are pretty creepy, but I feel like Face 5 is a bit too creepy. One or two commenters on Reddit made a good point that, as a receptionist animatronic, her design should still pass as somewhat friendly looking. And I think that makes a lot of sense. So Face 5 may arguably be more creepy, but Face 6 strikes a nice balance, I think. It can pass as both unsettling and friendly. Another critique I got was for all the designs, and that's in regard to the animatronic joints. The commenter mentioned that it doesn't really make sense for the endoskeleton joints to be so small, as that wouldn't really support the rest of the body. They suggested that I reference the Nick in Time animatronic Mangle redesign. I'd never heard of that before, but when I looked it up, I immediately knew what they meant. The commenter was referencing these parts of the endoskeleton where the limbs are held together by large, circular joints that are colored to match the exoskeleton shell. With mine, I had these larger balls encasing the smaller endoskeleton ones. So I just went through all my reference sheets and fixed them to match the Nick in Time design. But that's all for my animatronic designs. If you have any more suggestions, feel free to let me know, but I'm pretty happy with what I ended up with. When it comes to names, I received suggestions for the cat, the receptionist, and the bunny. 1 for the bunny, 1 for the receptionist, and 12 for the cat. Yeah, so there may be a little bit of a favorite. For the cat, I chose the name Chester, which was suggested by these two commenters. This name just felt perfect for him. For the receptionist, I chose the name Stella, which was proposed by this commenter. However, I did decide to adjust what it stands for to be Service and Task Electronic Labor Assistant. For the bunny, like I said, I only got one suggestion for her name, but I felt like it didn't fit. So for the bunny and owl animatronic, I did my own research to find names. For the bunny, I picked the name Penny, and for the owl, I picked Ollie. Now on to the next goal, modeling one animatronic. For this, I decided to model Chester, since he is the mascot of this game. I began with his endoskeleton, and for this I used Blender. Modeling is something I have a bit of experience in, as I have modeled a few of my characters before, just not for a game. This was actually easier to model than my previous modeling projects, mostly because all the intricate curves and details of a person are a lot more complicated than a blocky endoskeleton and the relatively simple curves of the exoskeleton. So for this, all I had to do was model it and then reduce the polygon count. I'll go more into that in a bit. While modeling the endoskeleton head, I realized that the proportions on my reference sheet were a bit off between the front view face and the side view face. So I fixed that and continued. Then I modeled the head and spine, then went to the torso, arms, and legs. Somewhere along the way, I also added in his endoskeleton tail and ears. For the tail, I decided to model it pre-curled, as it seemed like overkill to make an animatable tail. I'm not sure what I would animate it to do anyway, and it doesn't seem realistic for a large robot. The good thing about the endoskeleton of all the animatronics is that they're all pretty much the same, save for a few details. So modeling future endoskeletons should be much quicker, as I can just modify this version. Once I was done, I did some research on how many faces a game model should have. If you don't know, 3D models are made up of faces. When it comes to animating these 3D models and putting them into games, the number of faces can greatly influence the performance. In a game, it has to render lighting, which affects every one of those faces. So keeping that face count as low as possible is necessary to keep the experience optimal. Because of this, I had to go back in and reduce the amount of faces until I got it down to an acceptable level. I did have to give up some of the quality, but it won't be noticeable. I also tried adding wires, but that added way too many faces, and it wasn't really necessary for it to look good. It was at this point that I put the model in Mixamo, a site that can be used to animate 3D models quickly and easily. I won't be using this in the final product. I just thought it would be funny to make him dance. Back to Blender, I finished off by adding materials and textures to the model and rigging it. Basically just giving it bones so I can move the individual parts. The rigging took absolutely forever, as I kept running into issues with a variety of different things. I eventually got it to work though. It just took a lot of remaking it from scratch and researching. Another thing I did was reduce the hand controls, which may cause some issues further down the line when it comes to posing. If it does, I'll have to redo the rigging again. But hopefully that won't be the case. Next, I modeled the exoskeleton on top of the endoskeleton. The hardest part was the head, as I struggled to get these fur things on the sides look good at all angles. For a lot of the model, I had to increase the size of different parts because the endoskeleton was clipping through. The hands, tail, and rose were the 3 things I saved for last due to them being more complicated. The rose was the hardest, as roses have a lot of petals. They're probably one of the hardest flowers to draw as well. I ended up modeling a very simplified version of it. The hands and tail weren't as hard, just tedious. Then, just like with the endoskeleton, I went back in to reduce the faces. Unfortunately, I did have to delete parts of the endoskeleton that wouldn't be visible. It hurt to delete my hard work, but I did have a backup in a different file with the endoskeleton. I mixamoed this version as well. And finally, I made him look metallic and rigged him. At some point later down the line, I realized that more work needs to be done with Chester's model to make him look less perfectly smooth and shiny. Basically, I need to make him look more real. Hopefully, for my next devlog, I can get that fixed. The next goal was blocking out the map, which includes a lot more than just blocking it out. A lot of setup had to be done before I could actually get into it. This began with finally making a project in Godot, my engine of choice. Then in the 3D section, I blocked out a simple office and dragged my newly modeled Chester animatronic in. He's necessary to have in so I can scale everything according to his size. Afterward, I added in a basic player controller so I could easily explore the scene from the eyes of the player and test things. I looked at a few tutorials for this, mostly to implement better mouse movement and sprinting. For now, the player has infinite sprints, but I'll likely change that later down the line. I didn't add any jumping or crouching, but I may add that ability in the future. After getting that to work, I went back to my iPad to sketch out a basic layout of the establishment, making sure to include all the rooms I thought I would need. Let me know if there are any additional rooms a place like this should have. From that, I went back into Godot and began blocking out the map and its rooms, using my sketch as a guide. I played around with the sizes of each room a lot, using the player and Chester as references. Then I took it a step further and blocked out major features in each room so they would be more easily identifiable. This took much longer than the basic blockout. I think it looks pretty good so far. I maybe made some things a little too detailed for something that's basically akin to a quick sketch, but I couldn't help it. It was just too enjoyable. And last, but definitely not least, the final goal, coding the animatronic AI. Except I coded a lot more than just the AI. This is probably a good point to talk about my school. I've never mentioned this before, but I'm a game design major. School has been so busy these last few months that I barely had enough time to work on this game. However, as my final projects started creeping closer, I decided to make my FNAF game the final project for one of my classes. That way, I could actually have the time to work on it and make some progress. So for my project, I decided to make a full working prototype of the game, which is why I coded a lot more than just the animatronic AI. I basically added in everything that you would need for a classic FNAF game, plus more. I began with coding the two states, the security state and the free roam state. As I mentioned in my previous devlog, I want my fan games to be more than just the point-and-click gameplay of the classic FNAF game. Once the power goes out, I had planned for the player to be able to get up and move around so that they can switch the power back on. I coded these two states using something called enumerators, or enums. This was my first time using this data type, so I may or may not have done it wrong. I definitely had quite a few issues with it and understanding how they work. For my game, I have the security state and the free roam state, which affects a variety of things. At that stage of development, the free roam state was easy. I just needed the player to move and look around freely, which I already had with the player controller I mentioned earlier. What wasn't easy, and took me at least 10 hours to figure out, was getting the mouse to work correctly in the security state. If you played FNAF or seen any of its gameplay, you'll know exactly how it works. Your mouse starts in the middle of the screen, and moving it allows you to look to the left and right of the room. From there, you can click on the buttons on the walls to turn on and off the lights and open and close the doors. The issue I was having was that the player's mouse wouldn't snap to the middle of the screen, and the player wouldn't start out looking at the middle of the office. And this would become an even bigger issue if the player just so happened to be moving their mouse when the scene loaded. This is an issue because it may result in the player being unable to see and click any of the door or light buttons I would add later. I just could not figure it out at all. I even tried asking for help on Reddit and didn't receive much success there either. I tried looking at tutorials, reading documentation, etc. All to no avail. I had no idea what to do. So, unfortunately, I had to ask AI for help. It's not something I like doing. I like to be able to do everything myself. This is the code before and after using AI to help. These are the parts AI added, and then there are some parts it got rid of. It really isn't that much of a change, and I was skeptical that it would work, but it did. If any of you have a better way of doing it, please let me know. I coded everything else myself from my own coding knowledge, researching documentation, or watching tutorials. Now for the rest of the mechanics, which were much easier to figure out. I began with the cameras. I made the UI first by adding in a modified version of the map in the bottom right corner of the screen. Then I added buttons for the individual cameras and another button to open the cams at the bottom. The code for that button is simple. I have it so that it's always on screen. Then, when the player mouses over it, the camera UI becomes visible. Mousing over it again causes the camera UI to become invisible. Going back into the main scene, I added in around 11 cameras in the various positions that I needed them to be in. Then I went back to the UI and coded it to allow the player to switch the cameras when clicking the respective button. It was quite a lot of code, I'll admit, and very repetitive and ugly. Repetitive code is not good code in my eyes. I knew I could simplify it. I just didn't know how without some research. Apparently, you can actually connect each button to one singular custom function instead of 11 different functions. It was a little difficult for me to figure out exactly how it works, but I was eventually able to change the code from this to this. It's always quite satisfying when I can condense and refactor my code. Here's the function. It takes a number as a parameter. Every time the player presses a camera button, it triggers this function and inputs a number. The function then takes that number, finds the corresponding camera, and sets that camera to the current one. Except for cam 11, which is just a black screen. And that's it for the camera UI and code. I ran into a few issues, but otherwise got it working pretty quickly. Next is the time, the power, and the door and light buttons. All four were fairly simple to get working. The UI for the time was just a label with the time plus the letters AM. When it comes to the functionality, I added a timer that lasts 68 seconds. Every time the timer finishes, the time goes up by an hour. This is on par with FNAF 2, which has the same time frame for every hour, and this results in a night that's 6 minutes and 48 seconds long. I might change this time frame in the future. The power UI looks like this. It's a label that shows the percent of power the player has left and a progress bar for the usage. The progress bar can have a value between 1 and 4. Just like in FNAF, actions such as opening the cameras, turning on either light, or closing either door will cause the usage to increase by 1. And shutting these things off decreases the usage by 1. In every FNAF game, the power goes down passively by 0.1% every second, or 1% every 10 seconds. Originally, I simplified it and had this function decrease by 1% every 10 seconds, and this value would increase by 1 with every additional usage value there was. So the power goes down by 1% every 10 seconds if the usage is at 1, 2% if the usage is at 2, and so on. But there was a problem with this. Since my function only looks at the usage once every 10 seconds, the player could be in the cameras for the first 9 seconds, close them before the 10th second, and only lose 1% of power. This is easily exploitable, so it had to be changed to decreasing by 0.1% every second, more if the usage is more. And at the end of the function, it rounds the number to the nearest whole number and displays that. Later, I would end up increasing each by 0.1%. So the power would go down faster. The door and light buttons were more difficult as I had never made a 3D button before. I looked for a tutorial for forever, but it was hard to find a recent one that fit what I needed. But then I realized that it's really not that different from 2D buttons if the mouse is visible. You just use an Area 3D to test if the mouse is inside the button or outside of it. So, using this, I was able to code it so that the button changes color when pressed and toggles the visibility of the light. The door button was basically the same, except instead of toggling the visibility of a light, it plays an animation of the door sliding up or down. After all of that, I added a flashlight that the player can only use when the power is out. It was pretty simple to make, and I quite like the effect it has when it's dark. I then added an extra light in the office to illuminate it better in the dark, making sure to turn on shadows so it renders properly. However, this light would bleed into the hallway, which ruins the idea of hallway lights. So I added invisible light-blocking barriers to the doorways, and after all of that, I finally worked on the Animatronic AI, which I was dreading, but was actually pretty fun. I began with doing a lot of research on how Animatronic AI works in the original FNAF games. I think I watched about 3 videos, which I'll link in the description if you want to learn about it yourself. I won't go too in-depth on how the AI works in this video, but I'll give a brief overview. Each animatronic has an AI level that goes from 0 to 20. This number determines how often an animatronic moves. After a certain time interval, the AI will generate a number within that same limit and compare that to the animatronic's AI. If that number is less than or equal to the animatronic's AI, it will move. For testing purposes, I set Chester's AI to 20, meaning he moves every time interval. For now, I've set that time to 5 seconds, but that's subject to change. Next, I made a function that generates a random number every 5 seconds and compares that to Chester's AI. If the conditions fit, it calls another function which determines where he moves. The easy way to make this would be to use a lot of if statements. For example, if he's in the dining room, then move to the bathroom or the hallway. But that would quickly become very long and very complicated. So instead, I used 2 different dictionaries, one to determine where Chester can move called possible movement, and one to give the information of the specific coordinates of where he moves called room pos. I won't go too in-depth into what a dictionary is, as this video is already quite long. Just know that it is used to store valuable information. Basically, this part before the colon represents the current location of Chester. The part after the colon is a list of the rooms he can travel to from that room. So this line means if he's on stage, he can either go to the dining room, the hallway on the left, or the hallway on the right, and so on for the rest. For this dictionary, the part to the left of the colon is the name of the room, and the part to the right is the coordinates that Chester will be in for that room. The move animatronic function uses the information in the dictionaries as well as a variable that shows his current position to move Chester. It does this by going through every room in the possible movement dictionary and finding one that matches Chester's current position. Then it randomly picks one of these rooms as his chosen location. Next, it goes into the room pos dictionary, finds the room that matches Chester's chosen location, and uses the corresponding coordinate to move him to that position. The only exception is if his chosen location is the office. I had to add an extra line to check whether the corresponding door was closed. If it's open, he goes in and kills the player. If it's closed, he goes back to his stage. Oh, and I made a death screen too that brings the player back to the main menu after some time. I was able to get all this to work fairly quickly, although I may have made it too easy for Chester to get to the office quickly. I'll have to change his routing later. And from there, it was only a matter of coding Chester's AI for the free roam part of the game. This was pretty simple, as Chester is not one of the animatronics that can move around during the free roam section. I have decided that both Penny and Chester will not move around during free roam. They will be locked in place. I just feel like having 4 animatronics hunting the player in a place with narrow hallways and not a lot of room to escape would be a bit extreme. That doesn't mean they won't be a threat though, as they act as obstacles. Getting too close to either of them will result in a death. Stella and Ollie will be the ones hunting the player down. I'll explain what they do more in a future devlog, once I actually implement them. For now, Chester's stationary AI will have to do. I just have it so that his movement is paused when the power is out, and his position gets reset to the stage when the player returns to the office after restoring the power. Also, on the topic of free roam, I created the rest of its functionality. I did so by adding in the breaker that the player can interact with to restore power. I reused and redid the code from the light and door buttons, but it was a little more complicated than that. The issue I was having was that it was sensing when the mouse was over it. probably because the player mouse is captured when in free roam mode. This just means the mouse is invisible and the camera rotation follows it, just like any other first-person game. Area 3Ds don't sense a mouse that is captured. I fixed this issue by adding a raycast to the player, which is something used in most 3D games to detect if something is crossing it. It took a bit for me to understand it enough to use it, but I eventually figured it out. Once I did, I was able to make a working breaker that restores power by a certain amount and allows the player to return to the office. I also made it so that the player can only restore power twice throughout a night before it will no longer work, resulting in a death when the power goes out a third time. I used a similar strategy to make the computer, which the player can interact with to return to the security state. The computer can only be used after interacting with the breaker. Doing so switches the game back to the security state. When the power goes out, the time pauses. This prevents players from just hiding out for the rest of the night and winning by doing almost nothing. So interacting with the computer also resumes time. And from there, I playtested and fixed bugs. And that is finally all. I didn't realize how much I did until writing this. It was all a blur, honestly, as I had so much to do for this and other things. It was a lot of pressure, but I produced good work under pressure, even if it is rather torturous. I know I said I would take 1 to 2 months to do this, but most of the work was done in the last few weeks. It's no exaggeration to say that I am quite tired. But hey, at least I have a working, playable prototype. Now for the goals for my next devlog, hopefully coming out in another month or 2. First, I want to model the other 3 animatronics. Second, I want to implement all the animatronics. This includes their AI, posing, positions, animations, etc. Third, I want to model the entire establishment. Fourth, I want to do general polishing of code, graphics, mechanics, and more. And finally, I want to get the demo out. That's right, in a few months I plan to get a demo out that you all can play. The demo will consist of 1 night and will hopefully result in a lot of critique that will help me make the game better and more enjoyable. Let's hope I can achieve all of that. And if I can, I'll also try to put out a trailer. It'd be my first time making one though. Before I end the video, I just want to apologize for not getting out as many videos lately. School has been so busy, and I unfortunately had to prioritize that. But because of that, I have quite a bit of content to show you guys. So stay tuned for that. Oh, and thank you so much for 300 subscribers. Let's continue this wonderful journey together. But anyway, that's all I have for you today. Thank you so much for watching, and please consider liking and subscribing if you haven't already to see more of this kind of content. Take care and farewell.